Here's another payout annuity problem. In this case, I want to withdraw $3,000 each month for 10 years from an account that earns 5% interest. So how much should I have in the account to start with so that I can do that and have a zero balance at the end of those 10 years after making those monthly withdrawals? So let's take a look at what formula we might need to use for this. So it's a payout annuity, and the bottom two rows deal with that. One of them calculates P0, the present value. The other calculates the monthly or periodic withdrawal. So I know what the withdrawal is. I want to know what to start with. So that would be this second formula from the bottom. And I'm going to use the spreadsheet version here, PV, for the present value of this annuity. So let's give it a shot. To do that, I need to know a few things. So I'm going to use a spreadsheet again. So spreadsheet, the formula is PV, and PV wants to know what is the periodic rate. It's going to want to know what is the number of payments. Let's double check. I think it wants the payment amount or the withdrawal amount next. Yeah, the withdrawal amount. And so that's going to be an opposite. And again, that payment here is also known as a withdrawal. And then I think there's one more item there, which is either when we get the payment or what we want the final value to be. So we'll find that out in a moment in the spreadsheet. So things we need for sure is we need to know what is the rate. So we have our rate R, that's 5%. We need it as a decimal, although a spreadsheet will take a percentage. How often do we get that rate? So that would be yearly, but we're making monthly withdrawals, so 12 times per year. N in this case is going to be 10 years, and then we usually use D for that withdrawal, and that's going to be $3,000. Oops. So if we were to just type those numbers in a spreadsheet directly into PV, that would be our 5% divided by 12, and then it would be the 12 times, that's supposed to be an asterisk, 12 times 10, and then because we're moving through time, it's going to be a negative 3,000, and then followed by a 0. And that should calculate the initial value. Let's try it on a spreadsheet. And I already have a spreadsheet pre-built for this. I'm just going to show you how I set it up. Like when we take notes on a piece of paper in a spreadsheet, you should always have a statement for what the number means. So here I'm saying the periodic payment is, in this case, I want it to be 3,000. My APR, or what we call R, 5%, it's already here, so that's cool. Number of periods per year, that would be the 12, that's our K, and we're going to do 10 years, not 15. And I have this set up to do two different things. I have this box here already set up to use present value, and I have this box here set up to use the calculator version of that. So I'm just going to start over on that. So if you're on a clean spreadsheet and you have the numbers typed above, you would just do equal and start typing PV, and you can hit tab to accept or click on it or hit enter. Now the rate has to be the periodic rate, not just the 5%, but the 5 split into 12 months, comma. The number of periods, that would be 12 per year times 10. So we're just going to click on the 12 and then use the asterisk to multiply by the 10. So it's just pointing and clicking mostly. The payment amount has to be a negative, and we want to just click on that amount up above, comma, and it wants to know what is the future value. Now notice that is in square brackets, so technically I don't have to enter that, so I could just close the parentheses right there. And this says I should deposit, if I have $282,844.05 in the bank now, then I can withdraw $3,000 a month for 10 years, and at the end of that time, the account will zero out. All right, so let's think about that a little bit. Again, this is the calculator version of that formula. using the numbers above. I'm going to skip over that one for now. And number of total payments here. So total payments, that's just the $3,000 times 12 times 10. So if I click on that and hit enter, you can see that formula there. So again, it's the monthly payment or monthly withdrawal times the 12 months per year times 10 years from the cells above. So we started with $282,000, almost $283,000, but we were able to withdraw because of our interest rate a total of $360,000. So while our remaining balance were hanging out in the bank, they earned an extra $77,000 over that time, which is pretty phenomenal. Okay, so again, this is what's called a payout annuity, and there's two versions of the payout annuity. If you know the payment you want to receive, how much money do you need to start with? And other version is if you know what you have to start with and you know how long you're going to do it for and the interest rate, then how much you get to take each month. Pretty cool. Thanks for playing.